Hello, everyone. I hope you're doing well. Today, we are going to pick up from our last lesson where we learned about the three behaviors of light: absorb, reflect, and transmit. And we know that refraction happens when light transmits through something due to speed changes. So what I want to do today is share with you, if we were together in school, after we have this lesson, we would design a lab to model the different behaviors of light. So what I'd like to do today is, the best that we can since we're not together, is just kind of show you how the lab was set up, okay? So before I do that, I found this image, which I thought was pretty cool. It's a bunch of filters, right? It's a bunch of filter paper. Filter paper is, we've got red, green, blue, yellow, and orange filter paper here. And just take a moment to kind of study the diagram and critique it. You know, does it have accuracy? Do you see any issues with it? So one of the things that I would like to share is that this diagram does a really nice job kind of defining what filter paper is, as well as defining the term transmission. Because if you take light, white light in particular, and let it transmit or pass through red filter paper, only red will transmit and all other colors of white light are absorbed. Therefore, the paper glows red and you see red kind of peeking out on the other side. So orange, yellow, green, blue, indigo, and violet, they are all absorbed by the filter paper, and only red light is able to transmit. I like this diagram because it's telling you, if we see the color yellow, what's happening is our red and green cones are being activated because the red and green light is passing through to allow us to actually perceive and see the color of yellow. But if it's going to be orange, you're still getting red and green light, the same two frequencies or wavelengths of visible light passing or transmitting through, but more red than orange. So that's why I kind of like this diagram. I found it at the last minute and thought I'd share it with you. The one thing that I do not like about this diagram is that it's basically implying that white light is only made up of red, green, and blue. We have red, green, and blue cones in our eyes that are responsible for basically resonating and receiving stimulus from red energy, the red energy of visible light, the green energy of visible light, and the blue energy of visible light. But this diagram really should be showing white light entering the filter, unless the artist of this diagram is just trying to show maybe a red laser, a green laser, or a blue laser going through. If that's the case, then the diagram would be accurate. So I thought that would be just like a nice review of some light behaviors that we talked about before. Okay, so the behavior of light lab that we would have done in school. Before I show you what we are doing in the lab itself, let's recap doing a lab in our journals. It's been a while since we've done that. But if you remember, we used to set up our journals in A, B, C, D, E, F order, and letter D of the lab report was really important because it was about the experiment and how the experiment was designed and set up. And this is where you could identify all the important variables of the experiment. So remember, we've got 4 very important variables to an experiment. The independent variable is what the scientist is changing or manipulating, and they're making these changes intentionally or on purpose. The dependent variable depends on the independent variable. So the dependent variable is what you are actually watching, monitoring, keeping track of, measuring. And basically you're saying, how is the dependent variable responding to the one change that I made? And then the constant variables are things that are required in an experiment to make the experiment reliable, trustworthy, and fair. Because if something happens to the dependent variable, you want to be confident that the reason or cause for that certain observed behavior was due to the independent variable, the one and only thing you changed. In other words, all of the other variables that could have had an influence to determine the behavior of your results, you removed all of those possibilities and kept everything else the same, so that the independent variable truly was the only variable having an effect on the dependent variable. Finally, the control trial, or the control variable, is the one trial that does not receive the independent variable. So it's basically, how does that test sample behave naturally without the influence of the independent variable? So kind of like, how does it behave in nature? And then you're going to compare all other trials to it and basically say, see that the independent variable did have a significant impact or effect on the dependent variable. And here's proof, because this is how it would have acted in nature if it was left alone. But because I made this change, I was then able to observe special results in the dependent variable. Okay, so independent variable is what you change on purpose. It's what the scientist changes and manipulates. The dependent variable is what you measure, monitor, keep track of, observe and watch. The constant variables constantly stay the same amongst all trials and do not change. And the control variable, or the control trial, does not receive the independent variable. Okay, so in a moment, I'm going to ask you to pause the video and study this diagram. So again, what I've usually done as your teacher in class is I kind of show you the equipment and you infer the procedure, or I show you the procedure and you infer the purpose of the lab. I show you the equipment and the procedure and you infer the purpose of the lab and the variables of the lab. So I'm going to ask you to do that right now. I'm going to first just kind of show you a diagram, and by looking at this diagram, I want you to infer the procedure of the lab. I want you to infer some constant variables. I want you to infer the control trial. I want you to infer what is the independent variable in this lab, what is the dependent variable in this lab. So go ahead and pause the video, study the diagram, and when you think you've determined the overall procedure to the lab, can you generate a problem or purpose statement to this lab? Can you identify the 4 variables to this lab? When you think you've got it, then hit play and continue the video. So what you can see here is, out of the equipment, you are basically taking a light source and you're hitting a target. The target would have been a clipboard in our class, and the distance between the light source and the target is about 12 inches. Now, to make this fair and reliable, you can't use a 60-watt bulb and then a 40-watt bulb, right? Because the target's going to look different if you shine a 60-watt bulb or a 40-watt bulb. So you're going to have to keep the intensity or the strength of the light the same, right? I do not want you to think that the independent variable is the type of light you're using. So think of this as 2 separate labs with the same procedure. There's something else that you're changing on purpose that you're going to see as you look down on the second diagram here. So if you have to, look at this as 2 separate labs where you're going to do a bunch of trials using white light shining on a target that is 12 inches away from the light source. And you're going to use the same flashlight, the same light bulb, so that the light source is of the same intensity. And then that's the lab. And then I will say on a different day, you come in and you repeat that same lab, but you're using a laser light, because the laser light only releases one specific wavelength or frequency of visible light, which in this case, you guys would have been using a red laser light. So it would have been, you would have been observing a red dot on the target. So then what is the independent variable? And hopefully you see that it's the object that you put in the center here. So exactly at 6 inches, so 6 inches away from the target and 6 inches away from the light source, you are going to put an object. And what we're going to do is we're going to change the physical traits, features, or characteristics of that material. Okay? And then what you're going to do is when the light, whatever light it is that you're using, whether it's a flashlight shining white visible light onto the object, the question would be, look at your target. Is the target illuminated like it is in the control trial? Is it not illuminated at all? Is your target completely dark? Is it brighter? Is it dimmer? Did the color change? So not only are you looking at the target, but then you're also going to look at the material. Look at the material when the light does not shine on it, and then look at the material after the light is shining on it. And then by looking at the material and the target, you should be able to infer what behaviors of light are happening and using that as evidence to basically say, okay, let's classify the material. Is the material opaque? Is it transparent? Is it translucent? Is it very shiny? Is it very dull? Does it have a rough texturized surface, or is it smooth? All of these things, all of these conclusions you can make about the material based on how your target looks and based on how the material behaves when light shines on it. So when we change, take a look at the materials. Obviously, the control trial is no material at all, right? You want to see what the target would look like if it was not being interfered with a material in between. So we use saran wrap, filter paper. The filter paper is the red, green, and blue light that we used in our previous lab that I did as a demo. Wax paper. Wax paper is like parchment paper. It's like a milky color, and it's used for baking and cooking and things like that. Aluminum foil, black felt, white felt, cardboard, clear glass, a mirror, gummy bears, yummy, yummy, and your flesh from your fingertip. There's actually, I just noticed there's something missing from the list. It should be our black tabletop, our lab tables in lab, shining the light on the lab tables and then holding the target underneath that. Okay, so what I want you to see is that when we change the different materials, we're changing a lot of features or attributes or characteristics about the materials. For example, color, black versus white versus green versus red versus blue. Shape and size doesn't matter too much in this lab, but shape and size are physical properties of a material. Texture, smooth versus rough. Luster is basically the shine. Is it dull or does it have a high luster or shine to it? So obviously a mirror would be very lustrous, but black felt would have quite a bit of a texture to it and low luster. Malleability is it bendable? Can you fold it and then re-flatten it back out? So wrinkled versus flat saran wrap or wrinkled versus flat foil, you're just basically playing around with the malleability. Hardness is another one. It's another physical property. But basically, hopefully what you're seeing here is when we change the object or the material that we put at 6 inches, how will that affect the behavior of the light? And then ultimately, what's causing the light to transmit? Or what's causing the light to reflect? Or what's causing the light to be absorbed? It has to do with the physical properties of the material. So remember, to make a problem or purpose statement, we basically say, how does blank affect blank, right? How does the independent variable affect the dependent variable? So if we go back, what is the independent variable? Hopefully you see what you would have changed or manipulated on purpose in this lab was the material that you stuck in between the light source and the target. Remember that the type of light is not the independent variable because you're doing all of your trials with just the white light, and then that's considered one lab. And then I would have you do the lab all over again using just the red laser light. But what you're actually changing is the material. And what is it that you're changing about the material? Well, you're changing the color, you're changing the malleability, the luster, the texture of the material. In other words, you're changing the physical properties of the material. So then what is it that you're observing, monitoring, keeping track of? You're observing, monitoring, and keeping track of the target. Does it look different than the control? So you know what the white light would look like if it was shining directly on the target without interference of an object, a material in between. Same thing with the red visible light. So Did the light disappear on the target? Did it appear pretty much just like the control, like no change at all? Did the light, is it still there, but maybe change color? Or is it there and it became really dim because of what you put in between the path of the incident light ray from the light source and your target? So then you would basically look at, okay, well, it's got to be the physical properties of the material that cause the target to light up differently or not light up at all. So ultimately, if we go back to how does blank affect blank, how does the independent variable affect the dependent variable? It should be you're changing the material. When you change the material, you're changing the physical properties of the material. So what you're doing is you're basically saying, how do the physical properties of a material affect the way light behaves when light strikes that material? So then we have to say, well, what is the behavior of light? You learned that last lesson. The behavior of light is absorb, reflect, or transmit. So what I did is I took a picture of some of the things that I would have you do in lab, and I tried to photograph it and get it to show up, and I hope it does. But what you can see here is we have a red laser light shining through red gummy bears. Hopefully you see transmission. Do you guys see how the white paper, do you see that red glare? That is proof or evidence of what light behavior, guys? It's proof or evidence of transmission. Another piece of evidence that light is transmitting through the gummy bears is that the gummy bears are glowing in red because your light source is red visible light only, and it's transferring through and illuminating the red gummy bears. However, I'm going to argue that light is also reflecting. And the evidence of that are these 3 white dots. This is the glare that you're getting from some of the red light reflecting and bouncing off the gummy bear. And it's probably because gummy bears, as you know, are very smooth and they're pretty lustrous. You know, they're not as shiny as a mirror, but they have a pretty good shine to them. Ladies and gentlemen, I am going to argue and make the claim that not only is the red light transmitting through the gummy bears, reflecting off the gummy bears, but I'm also going to say that the gummy bears are absorbing some of that red light. What's the evidence of that? Well, I could get a before and after temperature of the gummy bears, and that's something that I would have had you done in lab, and you would notice that the gummy bears are a little bit warmer. That's evidence that some of the energy of the red light is being absorbed by the red gummy bears. The other piece of evidence that's pretty obvious that some of the light is being absorbed is that the light at the end is the red light at the end is very dim. The third gummy bear is barely illuminated, which means most of the light from the red laser light is absorbed by gummy bears numbers 1 and 2. Very little passes into the third, and that's why you get a very dim glare of red light transmitting out the other end. So then you would have used a white light, and you would have, again, you can prove that white light is made of red, orange, yellow, green, blue, indigo, and violet. Well, what we're observing here is that absorption is also happening. I can prove that by using white light because only red is transmitted. So you see that red glare on the paper. You also get some glare up here on the paper and down here. So some of the light is transmitting through the gummy bears and making it onto the paper. The third gummy bear is not as bright, but the evidence of absorption is that white light is made up of red, orange, yellow, green, blue, indigo, and violet. So red is the only one that's transmitted, and orange, yellow, green, blue, indigo, and violet are absorbed. And then look at this glare here. A lot of the white light, some of it is also reflected. So what light behaviors are you seeing when, regardless of the light source you're using, whether it's a laser light or a white flashlight, what are the behaviors of light that you're seeing? You're seeing all 3. And the key of this lab, guys, is that I was going to make you provide very specific evidence from your observations to prove the behavior of light. Then I was going to give you a green laser light, and you can see shining a green laser light on a green gummy bear The green light transmits through. There's the green making it through. It's also peeping through here on the paper. We got a glare here, so that's reflection. And we also can prove absorption because the third gummy bear is not as illuminated as the other two. So the green light is transmitted, the green light is reflected, and the green light is absorbed by the green gummy bears. But take a look at what happens when the red laser light goes on the green gummy bears. And I forgot to include the picture of me shining the green laser light on the red gummy bears, but you would have gotten the same results. So what you're seeing here is that the red light is not transmitted. It's either reflected at the surface. So some of the red light is being reflected off the shiny surface of the gummy bear, but then the rest of it is just absorbed by the gummy bears, and none of it is transmitted. So what behaviors are we seeing here? We're seeing absorption and reflection, no transmission. So how about the flesh? If I take a green laser light and shine it on my fingertip like I did here, I get a little bit of a reflection there, right? Because the green light is bouncing off the surface of my skin and I get a little bit of a green glare. But do I see anything transmitting? No, maybe a little bit right here. But what we're saying is mostly green light is absorbed by my finger or reflected off the surface. But what about a red light or a white light? So this is my finger with the red laser light, and you can see that the red laser light pretty much makes it all the way through. And if we were using the target of the clipboard, we would have seen a real faint red glare on the clipboard to prove that the red light transmitted through my finger. And that's because most of the substances, the liquid like the blood, is red in color, so the red is does not resonate with the red visible light, and it lets it pass through. And then here's white light to prove that. So orange, yellow, green, blue, indigo, and violet are absorbed by the finger, but the red is able to pass through. And you can see a little bit of the orange and the yellow do too, because it's not a perfect fine line. So some of the frequencies of orange and yellow also make it through the finger. So this is the red laser light shining on our tabletops, our laboratory tabletops, the black Formica tops. And this is at when I held the laser light at a very indirect angle. This is a direct angle, but as you can see, they're all dim. So what I'm trying to show you is that black is supposed to absorb all colors of light, but it's not ever perfect that you're going to see usually one behavior of light and one behavior of light only. So this is pretty much the result you would have gotten in class right here, a very dim red glow. So some of the red light, some of the energy, not all of it is being absorbed by the black color of the tabletop. Some is being reflected, and that's because, hopefully you could see why, the tabletop is a very smooth surface. Smooth surfaces reflect light pretty well. There's also a gloss or a sheen to our tabletops. They're not a dull color. And so we would say that they have a little bit of luster to them. And the more luster an object has, the better the chances of reflection. Okay? If I used a white flashlight on our tabletop, you're going to get a glare. So with the white light, not all of the white light is absorbed by the color black, even though we've learned that. But there's other properties about that substance, which is our tabletop in class. It's smooth, it's a little bit lustrous, which prevents all of the energy of white light to be absorbed by the color black in the black Formica of the lab table. But some of the white light is reflected because it's a smooth, lustrous surface. And you can see that it's not a bright light. It's more of a dimmer white light, but you're still going to get a little bit of a glare. So I want to just have you, I added, after today's lesson, I added a video clip about the world's darkest, blackest material. It's called Vantablack, which means it's the only material that's man-made where pretty much over 99% of white visible light truly is absorbed by the black, and less than 1% is actually reflected off. So it's a pretty cool video, just so you can see how engineers came up with that substance. The other video clip that I want you to watch is just 1 minute. It's just some results of the different materials in lab that we used. Like, what were the results? I showed you the gummy bear results, but what about the results with the felt or cardboard or the red, green, and blue filter paper? So the video clip is very quick, just showing you the results. And when I say results, the result is what is the behavior or behaviors of light that you witnessed or observed, and what caused those behaviors of light. And it has to do with the physical properties of the materials. Okay, so that is your lesson for today. I'm asking you to go and check out the 2 video clips to kind of supplement this lesson, and then you have a couple quick questions to answer for today's process grade. Okay, thank you. Take care.